Good afternoon everyone. First and foremost, I would like to thank Department of Physics and respected teacher Dr. C.P. Sir of Namchi Government College and Sikkim University to providing me such a platform to make a video of partial fulfillment for BSc Honours at 6th semester. My name is Fulkit Lepcha and my roll number 18NS0026. So for today my topic is semiconductor detectors. So for today my topic is semiconductor detector. Semiconductor detector. These are solid-like detector that can detect alpha particles or gamma particles. They are made of a semiconductor material. So before going to talk about semiconductor detector, we must know what is a semiconductor. Semiconductors are those materials whose electrical conductivity lies between those of conductor and insulator are known as semiconductor material. So, in energy band gap, in insulator, the band gap is much more in between valence band and conduction band. So, electron cannot jump easily from valence band to conduction band. So, it does not conduct electricity. In such cases, such material are known as insulator. Similarly, in a conductor, the band gap is overlap in between valence band and conduction band. So, electron can easily jump from valence band to conduction band. So, it conducts electricity. In such cases, such material are known as conductor. So, in between insulator and conductor, there is intermediate. So, in intermediate, the band gap in between valence band and conduction band is less than insulator. So, electron can jump from valence band to conduction band due to thermal excitations of electron. So, in such cases, such material are known as semiconductor. So, this is the energy band gap. Now the introductions of semiconductor detector. These are solid light detector that can detect alpha particles or gamma particles. They are made of semiconductor material. A semiconductor detector is a radiation detector which is based on a semiconductor such as silicon and germanium to measure the effect of incident charge particle or photons. In general, semiconductors are material organic or inorganic which have the ability to control their conduction depending on their chemical structure, temperature and presence of doping, etc. The name semiconductor comes from the fact that these materials have an electric conductivity between that of metal like copper, gold, etc. and insulators such as glass. They have an energy gap less than 4 electrovolt or 1 electrovolt. Semiconductor detectors are very similar in operation like photovoltaic panel that generate electric current. In a similar way, a current can be induced by ionizing radiation. As ionizing radiation enters the semiconductor, it interacts with the semiconductor material. It may excite an electron out of its energy level and consequently leave a hole. This process is known as electron hole pair generation. In semiconductor, the fundamental information carrier are these electron hole pair which are produced along the path taken by charged particle through the detector. By collecting electron hole pair, the detection signal is formed and recorded. Now the basic history. Semiconductor detector appeared on scenes on nuclear physics in about 1960. Mikey of Bell Laboratories had demonstrated the detections of alpha particles by semiconductor diode several years ago. In 1960, focus on relatively thin surface barrier germanium detector used as low temperature to reduce leakage current. In 1950, the first non-nuclear physics applications of semiconductor detector started to develop. This made development of first of energy dispersive X-ray fluorescence possible and has led to large commercial business which impact on many areas of research. So now the semiconductor detections mechanism. In semiconductor, the valence band and conduction band are separated. Due to the thermal excitation, the electron in a valence band jump to conduction band. Semiconductor are basically two types, p-type and n-type semiconductor. In semiconductor, we have p-n junction diode. P-n junction diode is made of a p-type and n-type semiconductor. Along the junction between the p-type and n-type material, the majority charge carrier in n-type are electrons. They can diffuse in p-type, and in p-type holes are the majority charge carrier and diffuse to the n-type. An opposite charge diffuse inside each other, then it basically recombine in very small region, so it create a depletion region. In the depletion region, neither there are free electron in conduction band nor hole in valence band. So it behaves as a nuclear detector to create a large depletion region. Therefore, we create a reverse bias case. In reverse case, PN junction is connected to some external voltage where the negative terminal of battery is connected to p-type and n-type is connected to the positive terminal of battery. In reverse bias, current is minimum in the circuit. However, what happens if an external nuclear particles enter the depletion layer? Then the effect of this particle lead to creations of an electron hole pair. Suppose an alpha particles enter the depletion layer, it basically collide with the atom or molecules in that region and transform energy. So this is the experimental setup for semiconductor detector. Now an electron in a valence band of that particle will absorb an energy and jump to conduction band lead to create a free electron and holes. So the effect of alpha particles inside the depletion layer is the creation of an electron hole pair inside the depletion layer. However, the number of electron hole pair create are extremely huge, energy ranging from 4 to 9 mega electronvolt. Since the amount of energy necessary to make a electron pair in a semiconductor around 3 electronvolt. So we can see alpha particle most million times greater energy than it is necessary to create an electron hole pair. That means one alpha particle with large number of collision can lead to creations of million of electron hole pair in the depletion region. And then this electron basically move through circuit, then it lead to potential drop across RL, which is detected through some kind of electron associate here. Some kind of existence of current pulse across RL is proof of existence of an alpha particle inside the depletion layer. Types of detector: silicon detector, germanium detector, diamond detector, cadmium telluride detector. In between them, silicon detector and germanium detector are well-used detector. Now, what are the applications of semiconductor detector? So, semiconductor detector found wide applicable in the detection and spectrometry of nuclear radiation. Semiconductor detector permit to obtain X-ray diffraction pattern from polycrystalline specimen using white radiation, provided that the angle between the X-ray beam and the immovable sample is constant. Semiconductor detector also used for medical application. In nuclear medicine, a gamma ray emitting radio tracer is introduced into the body and it by distribution is images using gamma camera. So these are the applications of semiconductor detector. Now, merits of semiconductor detector. Semiconductor detector play an important role in radiation instrument. They have many advantages due to their small size, good energy resolution in nuclear spectroscopy. The average energy required to create an electron hole is 10 times smaller than that of one radiated for gaseous detector. Silicon-based detectors are good for tracing charged particles. They constitute a substantial part of detection system at the LHC and CERN. Silicon detector can be used in strong magnetic field. So these are the advantages of semiconductor detector. Now, demerits of semiconductor detector. The semiconductor detector are more expensive than other detectors and require sophisticated cooling to reduce leakage current. It is difficult to large crystal with sufficient purity. The semiconductor detector have therefore low efficiency. Silicon detector also suffer degradation over time. As compared with germanium detector, the silicon detector has high FWHM. So from semiconductor detector, what we conclude is that an existence of alpha particles inside the depletion layer, which is given by the load resistant signal.